For this problem, I'm going to use the unit circle because it may, pens are all going to die. So there's bad unit circle, but find the length of the spring at 1 second. So we've got this equation. It's 33 plus 5 times the cosine of 720 times t. T is 1. So right now I know we have the length is 720 degrees. What's the cosine value of 720 degrees? Yeah, well, there's 360 degrees. There's 720. So what's the cosine value?
2. Half. 1.
What are, you've now gone all the way around, so you're back to right there, right? And what's its cosine value?
0. 1. 0.
Guessing.
Yeah, because it's either 1
or 0 because of the coordinates. That's 1, 0. Which is for cosine, which is for sine? The x or the y? X is for cosine. So the cosine of 720, all of that equals 1. So we have 33 plus 5 times 1. So we have 38. Now, did that make sense before we just sort of go away? And yeah, so now, I mean, a question like this, given 720 degrees, you just have to think about what would 720 be equivalent to. If I said, and just off to the side, if I said the cosine of, let me make life a little easy, 630 degrees. So 630 degrees is, there's 360, another 90, 450, 540, 630. So this is equal to me saying the cosine of 270 degrees. And the cosine value down there, this is now 0, negative 1, so that cosine value is 0. Okay? And so and this is why I'm using the unit circle here. I think it's a little bit nicer. Now
It also equals 1 on the graph.
Yeah. That's the thing. Nadine actually has drawn out the cosine. So there's 360. There's 720. And it's at 1. Okay. Is that right there? Again, I now have to switch my thinking to degrees because they're talking degrees.
It was 630 would be.
Yeah, 630 would be right there. So now, find the minimum length of the spring. If you think about it, we have 33 plus this. So the first thought is, well, add nothing to it, and that would be the shortest distance. Is that what you were thinking? Yeah. But is there a way we can subtract and even make it shorter?
Oh, you mean its shortest distance? when it's like
The-
contracted.
Yeah, so you think the spring goes down and then comes up and goes down, so what's its shortest distance? So what does that mean?
Would that be like -1?
Yes. There's a chance for cosine to be -1, or even think down here. So you could have 5 times -1. That makes sense? They kind of gave you a little bit of a clue here that 720 comes out to be 1, so we've added 5 onto the length. And because cosine can also have a negative value, then we could subtract 5. So, yeah, we're saying that the length is 33 plus 5 times -1. Here's the thing. They're not asking me when did that happen, so I don't actually have to know what degree that was. What I do need to realize is that cosine can have a -1 value. And so I'm just saying at some point in time this will be -1.
So we know that 38 is the maximum.
So 38 is the maximum, 28 is the minimum. So at what time at which the length is 33 centimeters?
When it is 0.
Right, when its cosine value is 0. And so the question is, at what time will that happen? Now, do you see what I'm writing here? I'm testing what Lummi just said. The formula says 33 plus 5 times the cosine of 720 times t. She's saying t is 0 seconds. So the cosine of 0 is equal to 1. Do you see why it's 1? Because if we go back, the cosine of like 0 degrees is 1. You want it to be the cosine of 90 degrees or 270. Up here, cosine, that value is 0, but the angle, the degrees, is 90. So what you really want now, well, how are you going to make that 90? So here's the thing. At t equals 0, the cosine of x is 1. So that didn't work. What I need is the cosine of x to equal 0, meaning, and this happens at 90 degrees or 270.
No. Okay, because at 90 it's 1.
The cosine of 90?
No. There's yeah.
Here's 180.
Oh, okay.
There's 90. We want to be adding 0 to 33. So we need this to be 0, which means we need this. We need
T to be 0.
this to be equal to 90. So the question is, 720 times t has to be 90. Nope. The first time at which the length is 33? 1/8 of a second. I might be changing my mind. I might like using the wave graph instead of the unit circle. Here's why. And I'm going to have to stand here like. Here's the graph. And we drew it all the way out to 720, right? Which, at 720 degrees at t equals 1. right? So this is t equals 1. When was it the first time it was at 0? It was over here. Now, t equals 0, right here. T equals 1 at 720.
I know, but that's simple. But you just add.
Kind of is simple.
Because it's 1, 2, 3. Because they're like solutions, the number of solutions. Or
It's not just the number of solutions, but look. 1, 2, 3, 4, 5, 6, 7, 8.
so if 1 is 8 over 8.
We've divided it into 8s, and the first time it was 0 was 1/8 of the way. And then, yeah, part D. Period and things we've talked about. This goes back to period goes back to this little formula 360 over b, where b is whatever we're multiplying here. So it happens to be 720. So